Okay, section 7.2, trig integrals. Once again, trying to figure out antiderivatives of stuff that we haven't had yet. So let's look at here's a theorem. We'll go case one. What if I have, so for case one, I'm going to have the antiderivative of sine to a power. So sine to the nth power of x with respect to x. The question is, what are we going to do here? Or we might have the antiderivative of cosine to the nth power of x with respect to x. So we know how to do it if it's just integral of sine x. The integral of sine is what? Minus cosine, because the derivative of minus cosine is the opposite of minus the sine, which is sine, which is right here, right? So we got that, but anyway, in this case, case one, we're going to let n be positive odd integer. And once again, so we're going to look for patterns here, but positive odd integer for case one is what we're looking at. And so what we're going to do is what we're going to end up doing is we're going to factor. So we're going to pull out, like if it's, let's just look at this one here. Let's look at this one, sine to the nth power. We're going to pull out a sine x, and then what are you left with? We're left with one less on the power, right? So if that's sine to the 7th, we're going to pull out a sine, you'd be left with sine to the 6th power as the other factor, right? So it's going to be, how do we write that in general? It's sine to the n minus 1 power of x. So we're going to factor it out like that, and then we're gonna do some things like that. So if this is odd, what do you know about n minus 1? It's even, okay? And why is that important? It's going to be divisible by 2. So what I can do is I could write it as something different. So I can write it as sine of x times sine squared of x, right, to a certain power. So I can rewrite this as sine squared of x. So if this is 6, obviously sine squared of x to the 3rd power, right? So how do I get that? I just take whatever that exponent was and I divide it by 2, right? So how do I write that in general? So I'm going to show you in general the theorems, similar to what we did on Tim's theorem in section 7.1, is it's showing it in general, so which looks kind of confusing, but the reality of it is it's not that bad. So now, why would we do this? Well, we can rewrite sine squared of x, okay, into something that we can handle. So sine squared of x, anybody know what that's? What relationship do you know with sine squared that has sine squared in it? That was on your trig sheet. Yep, so sine squared plus cosine squared is 1. Sine squared x plus cosine squared x equals 1. So if I want to solve that in this case, for the first type of problem, if I want to solve that for sine squared x, it's 1 minus cosine squared x. So I'm going to rewrite this as 1 minus cosine squared x to the n minus 1 over 2 power. So, and why would I do this? Because now that's going to be inside the antiderivative here instead of sine to the nth power, and I'm going to be able to use substitution. Okay, I'm going to be able to use substitution. All right, so let's look at an example of this. If I have the antiderivative of sine cubed of x with respect to x, and once again, so this we might say a positive odd integer bigger than 1, because if it's 1, we already know the antiderivative. So basically, starting with 3, we can start doing this. So we'll just do this easy one. We'll just do sine cubed. Well, maybe I should do it a little bit bigger. Should I do it a little bit bigger? I said sine to the 7th. Why don't we just do that one? How about that? Because I think they're going to have some easier versions in some of the odds for you to do. So anyway, how do I want to rewrite that? I want to pull out a sine x. That's what I want to do. Now I can't pull it out front because it's a function, right? But I'm just, when I say pull it out, I mean factor it out. So I'm going to rewrite this as sine x times sine to the 6th power of x with respect to x. Everybody agree? Okay. And then how do I want to rewrite that sine to the 6th power of x? I want to write that as sine squared of x to whatever power it would be. And what would it be? It'd be half of the 6, right? So sine squared quantity cubed. And then instead of sine squared, how do I want to rewrite this? So I've still got my sine x that I pulled out, but instead of sine squared, what do I want to put in? 1 minus cosine squared, right? So it's 1 minus cosine squared x, quantity to the 3rd power with respect to x. Okay, everybody good? Now that's equivalent. So sine to the 7th of the integral of sine to the 7th of x is equivalent to the integral of sine x times the quantity 1 minus cosine squared x quantity cubed. And I'll come back up top. You need to stand up to see the board or move around, move to the other side of the room, get a better angle. That's fine. Everybody following what I'm trying to do? Trying to rewrite it in a way that helps me take the antiderivative. So let me just rewrite what we had up here. We had the integral of now it's sine x times 1 minus cosine squared x quantity cubed with respect to x. So this is a function to a power. So what might you think we want to do? Methods of what we did in chapter 4. Wouldn't it be easier if that was a u cubed? Right? So we're going to let u equal 1 minus cosine squared of x. And then what do we got to do? I got to figure out what du is, right? So what's the derivative of that? What's the derivative of 1? Derivative of the difference is the derivative. Derivative of 1 is what? Yell it out so the camera can hear you. Was 0, right? So it's constant. And then now we got minus cosine squared of x, which is really like cosine of x quantity squared. So you act like it's okay. Drop that x, so it's power rule, right? So it's 2 cosine to the 1st power of x, right? And then times what? Yeah. Well, here's the problem with this. So times derivative what's inside, derivative cosine is minus the sine. Okay. So I guess this is probably what you would do. So this isn't going to work out as nice, right? Because then what's that become? By the way, I got dx. So I got the sine x dx, which I have sine x dx here, but then I've got this, right? So that ends up being a problem because I put that over here, and then I got that in the denominator, and I got u cubed over this. That didn't work out so good, does it? So what do? You actually have to cube that out. So that's what they're going to do. So I shouldn't have picked such a big one. That was a bad deal. So let me pick a big one. So we get a, so this, I can't just cut to the chase here, but what I can do is I can go ahead and cube that out. That's what we got to do. Anybody know Pascal's triangle? What's that? If I cube it out, I'm right here on this one. All right, so the first one, so what's this equal? This equals the integral of sine x times, okay, the first one cubed, the coefficient's 1, so 1 cubed is just 1, and then we're going to alternate signs, right? So minus 3 times, then this gets 2 of them, 1 squared is 1 times cosine squared. That gets 1 of them, and then plus 3, and then one gets 1, and then times this one gets 2 of them. So cosine squared squared is cosine to the 4th x, and then plus the last one gets the whole thing, and the coefficient is 1. So it's cosine squared quantity cubed, which is what? Cosine to the 6th. All right, but I'll let you cube that out, and this is all with respect to x. Okay, now what can I do? I can move that sign back in and attach it to each one, and then I'm going to be able to use substitution, okay? So if I do this, it's going to be the integral of sine of x with respect to x minus, now I'm going to take the coefficient out front. So it's minus 3 integral of sine x cosine squared x with respect to x. Everybody see what I did there? I'm just multiplying that sine x through each term. And then I'm pulling the constants out in front of the integral, right? Because I'm going to have to do a bunch of different integrals. Anyway, plus 3 integral of sine x cosine to the 4th x dx, and then plus 1 more. The integral of the coefficient here is 1 sine x cosine to the 6th of x. All right, now we're gonna team up. So we got different rows here. All right, I'll do the first one. I want the first. How many people we got? I want the first row. I want you to just do this one. And how would we do that? Let u equal cosine x, and then what's du equal? Minus sine x dx. So we can get rid of the sine x dx, right? So that's first row. You're green. Here's the second row. You get to do that one. And then the last row, the last 2 rows, is to do this one. And use substitution to do that. And of course, at the end, we're going to have a plus c. So you could all have plus a, I could have a plus a c1, you could have plus c2, plus c3, plus c4. But ultimately, we just need a plus c at the end. So don't worry about the constant. Front row, you got it? Okay, what we're going to let u equal? So let u equal cosine x, and then du equals minus the sine x dx, right? Which really, so sine x dx we have right here. And then what am I going to do? I'm going to pull out the minus, divide both sides by -1, or just have minus du. So this is equivalent to, I'm just going to get a plus sign there for the minus, right? So I took care of that. And then I've got, this is going to be the antiderivative. Instead of cosine squared, it's u squared du. Everybody agree? And the minus sign, I just made the minus in front a positive. Okay? So what's the antiderivative of u squared? U cubed over 3, plus a constant, but, which we're going to ignore because I got it already over here. But anyway, u cubed, and what's u again? Cosine. So this is now cosine cubed x over 3. Well, that's kind of nice, because what happens to the 3's? They'll cancel out. So this is going to be equivalent to minus cosine x, and then plus cosine cubed x, right? And then we see what we get on the rest of it. Everybody good with that? So we just have to do the substitution process multiple times, because I picked the bigger one. So we have a few more terms. Anybody do this one? Okay, and since I used u here, same problem. I'm going to say let w equal cosine x. I'll just use a different variable, and dw equals what? Minus sine x dx. Same deal. I got the sine x dx, and then I've got the minus sign. I'm going to get to the other side, whether it's on bottom or on top, doesn't matter. So it's the opposite of dw. So what can I do? Can I put that minus out front and then not worry about it? Okay, so I'm going to do that. That becomes the antiderivative of u to the w to the fourth dw, right? Yep. Which is w to the fifth over 5 plus a constant, which we're not worried about right now. And then w was cosine x. So this is cosine to the fifth x over 5, right? And then times minus 3. So it's going to be minus 3/5. I should have done that in red. So it's minus 3/5 cosine to the fifth of x, right? Not worrying about the plus c because I'm going to have it at the end. Okay. In fact, I'm going to put it there now so I don't forget it because that'd be minus 1,000, right? For favorite students. All right. Anyway, and then the last one, same deal. Who did this? Back 3. What'd you do? Okay, so you use u. I'm going to use z. Z equals cosine x. dz equals minus sine x dx. Okay, so that minus sign I'm going to get on the other side. The sine x dx, I'm replacing with dz. And the cosine to the 6 is going to be z to the 6. So this becomes the integral of z to the 6 dz. And instead of the minus sign, I was going to take care, I got to pull it out front. So it'd be minus that, which is minus z to the 7th over 7 plus a constant, right? Which I don't need. And z was cosine. So this would be cosine to the 7th of x over 7. So, and there's, it was a 1 in front. Wait a minute. I got a minus sign, right? I got to put that minus in there because I had it on the dz, right? I got a minus sign there. So it'd actually be minus cosine to the 7th of x over 7 plus c. All right, I got this part, I got this part, and of course, the derivative of what is sine, derivative of cosine is minus the sine, so it's minus cosine. That was the first part. So anyway, I got each part here, and then we do that. Okay, so we do have a process. Now, the bigger the tower, the more awkward this is because Pascal's triangle can get really big, right? So I'll do a personal favor for all of you playing along at home, and I'll try and not make that too big. Okay, so next time when I say, should I start with 3, you should say yes. Would have made our lives easier. But the good news is when you go through it's a process, right? So you could try something like sine to the 3rd power. The reality is you got to factor out that sine, and then you have sine squared, and then you rewrite it using our trig identity. That sine squared is 1 minus cosine squared, and write it to whatever power. That would make it equivalent to what was left after you pulled the sine out. Similar thing for cosine. You want to see one real quick with cosine cubed? Or are you good? Think you're good? You know you're good? Okay, so you should be able to do sine to an odd power, integral of sine to an odd power, or integral of cosine to an odd power. So like integral of cosine cubed, what are we going to factor out? You can factor out one of the cosines, right? You left with cosine squared, we'll rewrite that as 1 minus sine squared. Multiply it through again, and then do it piece by piece, just like we did. So try an odd where they don't have too big of an odd power. Okay, so that's one of the things. So once again, when we had for the second part, integral of cosine to the n power, you're going to factor a cosine x, and you're going to be left with 1 less here, but cosine to the n minus 1 power of x. This is even, and so what you're going to do is cut it in half. You're going to rewrite that as cosine squared, whatever half of that power is, which is n minus 1 divided by 2. And then we're going to rewrite this as, instead of cosine squared, 1 minus sine squared x to the n minus 1 over 2. Then we're going to multiply out and then distribute the cosine through there. So it's the same process what we just did. Okay. So that is how you do a trig integral when you have sine or cosine raised to an odd power bigger than 1. Good. Now we know, right? We have a way that we can handle that. And apparently, if they're teaching you this is the way you handle it, that's the best way, right? Like there might be other ways you can try and do it, but this is what people have done in the past. They're like, hey, this is what works out the best. So if you come up with something any better, you let us know. All right. Anyway, so here's another theorem. Once again, proven fact. So what if we have this is case 2. You don't have to worry about the case numbers. Case 1, we have actually through like 7 cases here. Yeah, I'm not going to ask you to use case 2 to do this unless you're looking at your book, right? All you need to know is, hey, I see sine to the 9th power. I got to factor out a sine and then rewrite what's left, okay, using that trig identity. That's all you need to know. But anyway, this is the second case that they look at is when we have the antiderivative of sine to the nth cosine to the mth, like Mary's power with respect to x. Okay? So if I have something like this, now we got to look at it. All right, well, is n odd, even, or what? You know, what's going on? Basically, you have at least one of them being a positive odd number. Okay? Where m or n is a positive odd integer. And instead of saying integer, I'm just going to write number. Okay, positive odd number. Because I mean, pi's not odd, right? That doesn't make any sense. So I'm just going to write number, which is pretty evident here. But what are you going to do? What do you think we're going to do? Like if I have, let's just try and make an easy one. What if I have the integral of sine squared x cosine cubed x dx? So that'd be an example. What do you think I'm going to want to do if we base it at all on what we did before? Okay, and you're going to want to factor out a cosine because that's going to make the rest of it be an even power, right? So if you have at least one odd power, we're going to pick the one that's odd, and we're going to factor out a cosine. So we're going to factor out, and it's going to be one of 2 ways. So you're going to factor out a sine x if n, which one? So I got m or n. What? Did they have n first? They do, don't they? They got n before m. Isn't that terrible? What's LMNOP? Why did they do that? So they messed me up. Where n or m is a positive odd. So sine if n is odd, so nod. Everybody agree? Nod, yeah. And then we're going to factor out a cosine x if m, which is what we said here for that power, if m is odd. Now, what if they're both odd? Dealer's choice. Great answer, Haas. Yeah, I like it. All right. So anyway, so here we go. What's this equivalent to? This is going to be equivalent to the integral of but they factor it out and put it at the end. You want me to put it at the end or the beginning? Huh? Beginning. So cosine x and then times sine squared x times what's left here is cosine squared x, right? Because one less, I factored out dx. And then what do you think I got to do? I got to do the same process of what I did before. And since I was doing it with the cosine, this is the one I want to rewrite. As what? 1 minus sine squared. Yep. So this is the integral of cosine x, sine squared x, which I don't really need these parentheses here, but then times 1 minus sine squared x to the first power, right, dx. I do need parentheses around that one because it's a binomial, right? So I got to have parentheses around that. Now, what do you think I got to do? Huh? Okay, well, what wizardry? So now I'm going to go ahead and take this. I'm going to multiply it through, right? By the way, if this was to a power, I'd have to, like, if I had this to the third power, I'd have to cube that out just like I did in the last example, right? Okay, I'd have to do that first. I don't need to do that here because the power was to the first power. So I got kind of lucky. That's why I like using 3s, not 7s. Otherwise, we'd have to multiply that out first. But then now I can multiply these two together after this is multiplied out if necessary, right? And what am I left with? So it's cosine x times sine squared x times 1 is sine squared x. And then minus sine squared times sine squared is sine to what? Sine to the fourth x, right? And then with respect to x, dx. Now, what did we have to do in the last problem? Now, what do we do? Multiply that cosine through, right? And then we got multiple parts to take the antiderivative. So if I do that, this is equivalent to the integral of cosine x sine squared x dx minus, and then I'm taking integral of the sum, or integral of the difference is the difference of the integrals. When I'm multiplying cosine x times each part, so sine to the fourth x dx. So minus the integral of cosine sine to the fourth x dx. And I'm just pulling that minus sign out in front of that, right? And so I have two parts that I need to do here, right? So how are we going to do that? Let's do these three, do the one on the right, and you four, do the one on the left. Okay, so people by the wall, by that wall, do that one. The other people do this one, and we'll see what we get. These colors here. Okay. U equals sine x. Du equals cosine x dx. Isn't that nice? Just like we did before. Cosine x dx, I'm going to replace with a du. So that becomes the integral du. And instead of sine squared, it's u squared. So that's u cubed over 3, plus a constant. If you want to put plus c1, you could. We don't really need that. I'm just going to put a plus c for my answer. Anyway, so what you get, who's the people over here? Anybody done yet? Yep, or you could write the 1/3 out front, 1/3 sine cubed x, okay, is the red one, right? When you back sub. And then over here, I'm going to use w. I'm sure you used a u, but that's okay. So let w equal, same deal, cosine x dw equals sine x dx. So I'm going to replace that. Well, no. I did that wrong. I want to let u, I want it u to the fourth, so I want it to be sine x. You didn't probably do this at all. So this becomes the integral of u to the fourth, w to the fourth dw, which is w to the fifth over 5, plus another constant c2, which we don't really need to worry about that. But what's this become? And I had a minus sign in front, right? So don't forget that. Yep, so minus 1/5 sine to the fifth of x, and then of course, plus a constant at the end for a family of antiderivatives. One thing that I'll give Garrett like future credit, he said, hey, if you got a definite integral, by the way, we got a bunch of people gone today, but if for other activities. But anyway, if we know if it's a definite integral and you did a piece of it, instead of carrying all those terms with you, you can go ahead and evaluate that piece from A to B and then just carry the constant. So that makes a lot of sense. So back in 7.1, we had a few of them, especially ones that turn in, where there was going to be a whole bunch of different terms, but it was a definite integral. So you could just figure out what the number is and just carry that number forward and figure out the rest of it when we had to do the reduction process, stuff like that. So anyway, now, by the way, how do you know we're right? Check it. We can take the derivative of this thing if you want. So let's just real quick, how would you do that? You act like it's okay. It's sine quantity cubed. So 3, drop that 3 down, power rule, that cancels out. Sine squared times the derivative of what's inside. Derivative side is cosine. And anyway, so that ends up being this first one. As long as we did the process to get to this first one right, we're good to go. So any questions on this? So we've got a couple of things. Which one did we do here? We did, for this particular problem, we had cosine was odd, and so, or it had the odd power, so we factored out a cosine x, right? So whatever one is odd, factor that one out. If they're both odd, dealer's choice. Okay, and then work with the other one, reduce it down as like cosine squared to whatever power is left. Okay, so if it was just real quick before I stop this, and you don't have to write this down, but let me just change the problem. If I made this cosine to the 7th and I factored out a cosine, what am I left with? I'm left with cosine to the 6th, right? Well, that'd be cosine squared quantity cubed, which means I would rewrite that as 1 minus sine squared x quantity cubed, and then I'd have to do what I did with that Pascal's triangle, or multiply out the binomial and then multiply through again using the distributive law twice. If you're not good at that Pascal's triangle in your head, I just hope I did it right since I was on film. So anyway, remember this: if you want to be great at something, it might as well be everything.